Welcome to The Explainer. Today, we are decoding one of the most prevalent, profitable, and honestly sneaky client-side attacks on the entire internet, cross-site scripting, or XSS for short. If you've been following web security at all, you already know this is a total heavy hitter. But today, we're really rolling up our sleeves. We're breaking down the actual mechanics of how it operates, and more importantly, what it reveals about the fundamental vulnerabilities in our larger client-side trust models.
$4 million. Let that sink in for a second. That staggering amount is exactly what HackerOne paid out in bug bounties for XSS vulnerabilities in the year 2020 alone. I mean, that perfectly illustrates exactly why this persistent OAuth top 10 threat requires our immediate attention, right? Understanding the anatomy of this attack isn't just academic, it is absolutely critical for anyone building or navigating the web.
Okay, so here is our roadmap. First, the client-side battlefield. Second, mechanics of a hijack. Third, the flavors of XSS. Fourth, escalating the attack. And finally, number 5, defending the web.
Part 1. The client-side battlefield, hunting for weaknesses.
You know, we usually picture hackers in dark hoodies breaking into heavily fortified, uncrackable server vaults. But in the realm of client-side attacks, the battle is actually happening right on your own screen. Digital detectives, like the bug bounty hunters we're talking about, are navigating the exact same web pages you and I use every single day, just hunting for these microscopic weaknesses hidden in plain sight.
So what's the underlying philosophy here? It all comes down to exploiting the absolute trust your web browser has in its host website. It's essentially a modern-day Trojan horse scenario. Because your browser fundamentally trusts the site it's loading, it will blindly execute a malicious script if the server accidentally serves one up as part of the page. It's a fundamental breakdown of web architecture.
Moving to Part 2, mechanics of a hijack, gears under the hood. This is where it gets really fascinating. XSS actually weaponizes that browser trust we just talked about by confusing the application's logic. Think about safe data input, just standard HTML rendering a harmless message. Now imagine a malicious script payload injected into that exact same space. If the web app fails to sanitize this input, it actually stops reading it as harmless text and starts running it as a program.
So where do they find these weak points? Attackers hunt for interactive inputs. Think about a completely innocent welcome page and compare that to an interactive email subscription form. It's in forms exactly like that, where attackers try to trick the server into reflecting an inline script right back to the victim's browser.
As security expert Vicky Lee notes, the victim's browser will then execute the malicious script, which might steal cookies, leak personal information, change site contents, or redirect the user. And this is the crucial takeaway for you. This isn't just about rendering some harmless, annoying little pop-up. No way. We're talking about a total, devastating hijack of the victim's active session.
Which brings us to Part 3, the flavors of XSS, attack vectors.
Because the web is so incredibly vast and literally no two sites are built exactly the same, hackers have developed a whole diverse arsenal of XSS variants. We've got stored, reflected, DOM-based, blind, and self-XSS. These flavors basically dictate exactly how the payload gets delivered. It ranges from reflected XSS, which usually means tricking you into clicking a poison link, all the way to blind XSS, which secretly targets backend administrators by executing payloads in server logs that the attacker can't even see.
Let's zoom in on stored XSS for a second, because this one is widely considered the absolute most dangerous variant. Here's how it works. First, the attacker injects a script straight into the database, maybe through something as simple as a forum comment. Next, a victim visits the infected page, and boom, the script executes automatically without any warning. The terrifying part here is the scale. A single infected comment will silently attack every single user who simply views that page.
Part 4. Escalating the attack, beyond the bug.
Okay, to really understand how a tiny bug turns into a massive breach, we have to talk about the same origin policy, or SOP. This is a critical internet rule that restricts how a script from one origin can interact with data from a totally different origin. It's basically the invisible wall keeping your banking tab from reading your email tab. But an XSS exploit completely bypasses this defense. Why? Because the malicious script is running from inside the trusted origin. The browser literally thinks the script belongs there. Because the browser interprets the attacker's hidden message as a script rather than plain text, it basically becomes a ghost in the machine. It is completely invisible to the user, but fully 100% trusted by the browser, and that allows it to quietly read your private data straight off the active page.
Once they have that foothold, the escalation really begins. They could be stealing your session cookies, bypassing CSRF tokens, phishing with fake login pages, or even achieving a full account takeover. Armed with those stolen cookies or captured tokens, the attacker can force password changes, trigger unauthorized bank transfers, or even dynamically rewrite the web page to present a fake login and steal your credentials directly. The damage really goes exactly as far as the application allows.
And finally, Part 5, Defending the Web, Countermeasures.
All right, take a breath. Fortunately, developers are not completely defenseless here. There are highly effective countermeasures to patch these vulnerabilities before they get exploited. The primary defenses are input validation, which means literally blocking suspicious data right at the door, and output escaping. Output escaping is an absolute game changer. It converts symbols like angle brackets into harmless HTML entities, so the browser interprets them strictly as text, not executable code.
However, as you might guess, attackers are relentless. They constantly try to evade these exact filters using really clever tricks. They might prematurely close out HTML tags or alter capitalizations just to confuse the security checks. It's this nonstop, intense arms race between the security filter and the malicious payload. So, to truly lock things down, developers have to go the extra mile. They rely on modern frameworks, like React, for example, that automatically escape data by default. They also set HTTP-only flags on session cookies, which hides those cookies from JavaScript entirely, rendering any cookie-stealing payloads completely useless. Plus, they implement strict content security policy, or CSP headers, to outright block unauthorized scripts from loading in the very first place.
All of this leads us to a pretty crucial question. As browsers continue to get smarter and frameworks automatically escape our data, what will the next generation of client-side attacks actually look like? This high-stakes game of cat and mouse is far from over, and it leaves us wondering just how attackers will innovate their next Trojan horse. Thanks so much for joining me on this explainer, and remember, keep your curiosity sharp.